Welcome to The Explainer. Today, we're diving into a pretty wild idea that could help giant cargo ships glide through the ocean on a carpet of bubbles. I know, it sounds a little like science fiction, but it's very real, and it's the focus of a new study from the European Maritime Safety Agency that's all about making global shipping a whole lot cleaner. So what this study is really getting into is one of the biggest challenges in global trade. Shipping is the lifeblood of our economy, but it also has a massive environmental footprint. This tech, called Hull Air Lubrication, could be a way to seriously cut down on that impact.
It sounds like a weird question, right? But believe it or not, the biggest thing holding a 200,000-ton ship back isn't just its incredible size. It's actually an invisible anchor, the constant, relentless friction of water dragging against its hull.
Now, because of this friction, ships have to burn an unbelievable amount of fuel just to push themselves forward. And all that burned fuel, well, that translates directly into massive carbon emissions. It's a huge problem that engineers have been trying to crack for a long, long time. So the name of the game is pretty simple. You have to reduce that friction. If you can somehow make the ship slipperier as it moves through the water, you're going to use less fuel, and that means fewer greenhouse gases go up into the atmosphere. The real trick, though, is figuring out how you break that powerful grip the ocean has on the hull of a ship.
So how do you actually do it?
Well, the solution is super clever, and it works on a principle that you might have seen before, on an air hockey table.
It's called a Hull Air Lubrication System, or ALS for short. The whole idea is to stop that massive steel hull from dragging through dense water. Instead, you get it to glide on a cushion of something way less resistant. You get it to glide on air.
And here's how it works in practice. You've got these powerful compressors on board that generate just a ton of air. That air then gets pushed out through special units built right into the ship's flat bottom. What this does is create a consistent layer of tiny bubbles, basically a bubble carpet, that physically separates the steel hull from the sea. Now, you'd think this would be a total game changer for every single ship out there, right? Just flip a switch, save a bunch of fuel. But this is where the story gets really, really interesting. Turns out this brilliant idea is definitely not a one-size-fits-all kind of a deal.
What that EMSA study discovered was that the effectiveness of this one technology varies. And I mean, it varies dramatically. It all comes down to the specific type of ship you install it on.
And just look at the difference here. It's kind of wild. Air lubrication works great for almost 90% of container ships. But for tankers, it's only a good fit for about 22% of them. So what on earth is going on? Why is there such a massive gap between these different ships? Well, the answer isn't a problem with the technology itself. Nope. It all comes down to the fundamental design of these vessels and what they were built to do in the first place. See, it turns out there are a few key things that really determine how well this whole bubble carpet idea works. The big ones are the size of the ship's flat bottom, how fast it's going, and something called operational draft, which is just a fancy way of saying how deep the ship is sitting in the water. Even the weather can have an effect. And this right here, this explains everything. Think about a container ship. It's got this huge, wide, flat bottom, basically the perfect surface for trapping that bubble carpet. Plus, they tend to sail at a pretty consistent depth. Now compare that to a tanker. Its hull is more rounded, and its draft changes like crazy when it loads or unloads all that liquid cargo. All those precious air bubbles, they just escape right out the sides.
Okay, so it's not a silver bullet for every ship, but what does the big picture look like? Can this technology still make a real, meaningful difference on a global scale?
The potential is still absolutely enormous. The study figures that if this tech were put on all the ships where it makes sense, we could cut annual CO2 emissions by 3.5 million tons. To give you some perspective, that's like taking more than 750,000 cars off the road every single year. But when you zoom in on individual ships, the story gets a bit more complicated. An LNG carrier, which has just the right hull shape, might see fuel savings of over 4%. That is a huge deal. But a large container vessel, even with that flat bottom, might only save less than 0.5% in real-world conditions. It all comes down to that unique combination of the ship's design, its speed, and its day-to-day job. Still, even with all these complexities, the shipping industry is clearly paying attention. There are already hundreds of vessels using this tech right now, with hundreds more being built. It's especially popular for ships where it's most effective, like those LNG carriers and even cruise ships.
So, after going through all this data, what's the really crucial point? What's the main takeaway here? I think it's a powerful reminder that when it comes to green technology, there really are no magic bullets. The tech itself is only half the story. The other half is all about how and where you apply it. A brilliant solution for one type of ship might be almost useless for another. It's all about context.
And hey, don't just take it from me. The MSA study itself basically says the same thing. They conclude that the industry still needs more real-world data to fully get a handle on the potential and the limitations of this really promising but also really complex technology. Which kind of leaves us with a final thought. When we're looking for the next big thing to solve our problems, maybe the question we should be asking isn't just, does it work? Maybe a much better question is, okay, for whom and under what specific conditions does it work best? The answer to that is often a lot more complex and a whole lot more interesting.